Okay, picking up after our short break, we're going to continue our discussion of logarithms. And there are three rules of logarithms I want to state. These are called properties of logarithms. And they have names. The first one is called the product rule of logarithms. Log base b of m times n. Let me put a little dot in between here to emphasize multiplication. That's log base b of m plus log base b of n. So we have the log of a product. We can write it as the sum of two logarithms. Next is the quotient rule of logarithms. Most people sort of guess, okay, if we can rewrite or separate multiplication with addition, if they just had to guess, they're going to guess, okay, we can probably redo division, that's what quotient is, as subtraction. Log base b of m minus log base b of n. And finally, the power rule of logarithms. Log base b of m raised to the n power. If you have an exponent here, you can bring that down in front and write it as a factor. By that I mean multiplication. N times log base b of n. Now, these rules follow primarily from these exponent rules here. And one day I might make a video justifying these rules. It's a nice little justification. So I'm not sure, see how much time I have. If I do, I'll make a separate video justifying these properties of logarithms. If not, you're just going to have to accept them, okay? Now, we can use these rules to expand logarithms. And I'm going to go through and do an example. And it's going to seem like a pretty lengthy example or showing steps, but then once I'm through with this example, we're going to see if we can do it all without showing the steps. So I'm going to be expanding a logarithm. Expand. Let's say, you know what? Since I've already mentioned that if you just say log, that's log base 10, and the earlier, remember, if you write log without a base, we call that log base 10. Or we assume it's log base 10, it's called the common logarithm. Just to sort of make this thing look a little bit cleaner, the example I'm going to do right now is just going to be log base 10. So we don't have to write out the base over and over. Let's expand this logarithm. A squared b to the 5th over x to the 4th y cubed. And when I say expand it, I mean we're going to use the three properties of logarithms. Another way these instructions might appear, instead of using the word expand, it might say, okay, write it as sums and differences, okay? But the way we're going to go through this is we're going to start off using this quotient rule. Using the quotient rule, we can take this big logarithm here and write it as log of the top minus log of the bottom. So it's using the quotient. I'll put QR for quotient rule. Quotient rule says we can write it as log of the top minus log of the bottom next. We're going to use the product rule. The product rule says wherever there's multiplication, we can write it as the sum of two logarithms. So I'm going to put a little dot here to indicate where the multiplication is. So it's going to be log a squared plus log b to the fifth, then purple minus log x to the fourth plus log y to the third. Now, I'm not, what I've written here, it's not completely right. I want this subtraction to apply to all of this. I want this subtraction to apply to all of this. So if I put parentheses around there, I want the subtraction to apply to this whole, both of these terms. What am I trying to hint that we need to do with this minus? Yes. Did you hear that? Distribute the minus. So that's the next thing I'm going to do. Distribute minus. So we have log a squared plus log b to the fifth, then a minus log x to the fourth, and a minus log y to the third. So we've used the quotient rule, the product rule, then we distributed this minus. One rule we haven't used, the power rule. This PR is product, not power rule. The power rule we're about to use, power rule says we can move that exponent down right in front of the letter L. So take these exponents, I'll write it in black. 2 log A plus 5 log B minus 4 log X minus 3 log Y. Now, so this is called expanding a logarithm, or the instructions might say write it as sums and differences. So the question is, can you go from here to here without doing those steps? Let's make some observations. I think you can go from here to here without showing all of that, because that's how I'm going to be doing it. Well, the letter in front of the number in front of the letter L, that's the exponent up here. The stuff that's in the bottom has what sign, plus or minus in front? Well, a minus. So the stuff that's in the bottom has a minus in front of it. The stuff on top has a plus in front of it. And you're separating it wherever there's multiplication and division. So like to go from here to here, you're separating it, multiplication and division. 1, 2, 3, 4. So there are 4 different logarithms. Let me make up another one. Oops. Let's just try to expand this logarithm. This time I'll put a base on it. Log base 2 of w to the fourth, c to the fifth, over a squared x to the fourth y. Well, we separate these things wherever there's multiplication and division. So there. So there's going to be 1, 2, 3, 4, 5 logarithms in our answer when we expand it. The stuff that's on top has a plus sign in front of it, or it's the understood plus, like this one right here, the a squared. We didn't write the plus there, but we sure assume it's there. The stuff on top has pluses, the stuff on bottom has minuses. So there's going to be how many minuses? How many minuses will there be in the bottom? 1, 2, or in the expanded form, well, 1, 2, 3. So just to get started, the exponent goes in front of the letter L. So 4 log base 2 of W, then a plus, because the c to the 5th is on top, plus the 5 goes in front of the letter L, log base 2 of c. Now we've moved to the bottom. The exponent goes in front of the letter L, the x of 4th is in the bottom, so we put a minus. The 4 goes in front of the letter L. The y, well, there's not an exponent on the y other than the assumed 1. So I'm just not going to bother putting a number in front of the letter L. If you want to put a 1, okay, log base 2 of y. Notice 1, 2, 3, 4, 5. We have 1, 2, 3, 4, 5 logarithms. The exponents are in front of the letter L. The stuff that's on top has pluses in front of it. The stuff on the bottom has minuses. Okay? Let me see. I'm going to do problem 10 next. Here it is. Well, when you first see problem number 10, you're going to be like, well, wait a minute. We haven't done anything like that. But I've given you everything, or I've said everything you need to know in order to figure out how to do number 10. We know, remember, we know how to rewrite radicals. A square root you can write with a 1/2 exponent, a cube root of 1/3 exponent, and so forth, a 4th root of 1/4 exponent. So on number 10, there's a little bit of work you got to do first. Rewrite without those radicals. Let's see, I'm going to do these in color. A square root is a 1/2 exponent. Now this next one, it's a 7th root. That would be a 1/7 exponent. And on the z, it's another square root. So a 1/2 exponent. So to expand this, first you rewrite the radicals, the 3 radicals, as a square root's a 1/2 exponent, a 7th root a 1/7 exponent. Here the square root is a 1/2 exponent. So, now let's separate it. To separate it, 1, 2, 3, 4. There are going to be 4 logarithms. How many minus signs will there be in the answer? 1, 2. So we want 4 logarithms, 2 minus signs. Just looking at this is a multiple choice here. So knowing that, you might be able to figure out. Sometimes students tell me, oh, I can get the answer just once you've written it like this, just looking at them and stuff. And that's great. Yes, you should, if you can do that. I'm going to go to write it out for illustration purposes. The exponent goes in front of the letter L. So 1/2 log base 7 of x. plus because the y's on top, 1/7 log base 7 of y, then a minus, y minus, well, it's on the bottom, 5 log base 7 of w, and then another minus 1/2 log base 7 of z. So there it is. Let's see, which one is it? Well, it's A, isn't it? Now, a little word about this cannot be simplified. Sometimes students don't understand the importance of why am I saying putting these little dots here and so forth. You separated multiplication and division. If you had a problem that looked like this one, here's one that couldn't be simplified. If we had log base 7 of x plus y minus z, this one can't be separated. It can't be simplified. The natural wrong thing that students do is they sort of distribute the log7 as if it were a number. But no, this isn't log times. You can't distribute this. Okay? This one right here cannot be simplified. You can't expand it. Okay? Log base 7, you can't separate logarithms over addition or subtraction. Which one could you separate? Well, you separate at multiplication and division. This one could be separated. Right here's multiplication, right there's division. What would the expanded form look like? Well, there's no exponent, so you just say log base 7x plus log base 7y, and then a minus log base 7 of z. See, here's the one, looking at these two problems. How many people, if this were a multiple choice question and they had this one right here in green, would choose this as an answer? Because that'd be wrong. This one can't be simplified. You see the significance why I put these little dots here and try to indicate the division? You're separating at multiplication and division. Now, we're sort of out of time, so I'm going to pick up and do more the next time. So at this point, we've worked on this assignment 1 through 7, and we've done problem number 10. Okay? And you may be thinking, well, what about number 8? We're going to go back and do 8 and 9 when we pick up. Okay? So that'll be the third part of this video. Thank you for listening, and be working on these logarithms.